So we're now moving on to addressing some of the problems that we have with our buildings that we have existing. So to start us off, we've got Joanna Saady, who is from Ecotecture, Ecological Designs Limited, one of our local architects. Thank you.
Good evening. Good afternoon. No, good morning even. That's a wonderful start. So thanks very much, Jim, for inviting me to come along and talk today. So when I wrote this this presentation a couple of days ago, the PowerPoint got corrupted, so I rewrote it. So I think you've got the second version. I don't think it's quite as good as the first version, but please bear with me. So my name's Joanna Saady. I'm an early pioneer of green building. So I qualified as an architect in about 30 odd years ago. And then I went straight on to do an MSc in energy efficient building when nobody was, I think it was the second year that actually ran. So leading on from that, I then joined a very small organisation called the AECB. And I don't know if anybody's here has heard of that, but they were the original sort of green pioneers that came out of the 70s. The AECB stands for the Association of Environment Conscious Building. So after joining the AECB, I went on to become a trustee. So I went on to be a trustee, and during that time, we set up the Passive House Trust. Now, I don't know how many of you know much about Passive House, but the way that we design in my practice is we follow the fabric first principle. This is something that's only really just being adopted in building regulations, but it's absolutely key, I think, to energy efficiency. So when I was preparing this talk, I obviously had to look up when the Victorian and Edwardian era actually was, because the dates I didn't actually totally know. So Queen Victoria obviously had a great long time. For 63 years, I think she reigned, and poor old Edward only got 9 years to lay his mark. And it's quite difficult to tell the difference between some Edwardian and some Victorian buildings. So I don't know how many of you recognise these buildings here today. I'm thinking I've got them quite right. So basically what we've got is we've got lots of different shapes. So passive house principles talk about surface area to volume ratio being the key to energy efficiency. So the more angles that you have on a building, the more likely it is to leak out from those angles. So you actually need a very simple building to be very energy efficient. And obviously our Victorian and Edwardian buildings aren't. The way I can tell, I think, these two in here is that the one on the left is symmetrical and the one on the right is off-centre, and that's the typical characteristic for Edwardian and Victorian buildings. So I would just like to say that most recently, I've always had the eco-nut head on. I've always been very focused on reducing energy use and sod the heritage. And now, of course, I'm very different to that because I'm the South East branch chair for the Institute of Historic Building Conservation, and I've done extra qualifications. So I've got, sort of 3 decades of working in this business, and I've seen a huge amount of changes in that time. 10 years ago, I was advocating gas central heating as the most energy efficient in terms of carbon emissions, whereas now we're all going electric. So it's actually really quite confusing even for me. Next. So I don't know whether you know this, of course, but obviously 38% of our buildings were built before the war. I think there is a possibility that in Eastbourne, that percentage is actually a lot higher. The couple of little slides that I've got here show a Victorian building with a very interesting addition, which was done in the 50s. Now, I actually really love our solid old buildings, and I'll go on to sort of cover the characteristics of the actual buildings of Victorian and Edwardian themselves. But probably one of the worst periods of building for energy efficiency and for air tightness is the sort of 50s and 60s and possibly the 70s. So here you have a beautiful solid Victorian building with a 1950s, 1960s flat-roofed extension put on, and this will create problems with your junctions. Unfortunately, the modernist movement, which was very much about beautiful, sleek buildings, it got watered down and rolled out. So it absolutely, by the time it sort of petered out of fashion, we were just seeing horribly designed blocks like this. So barriers to energy efficiency measures, I've listed a few here, but it's really important that you understand the way your building works. So the bottom slide is actually, we clad all this with insulation, added a pitch roof so we improved the way it looked. It's actually got a turf roof on it, so massively reduced the energy consumption through heating, being a lot easier. Next. So it's really important to understand the characteristic of your older building if you're looking at doing any work on it. So, I'm personally a great fan of thermal mass, but obviously if you've got a Victorian or an Edwardian building, it's going to have solid walls. It might have some cavities. The cavities started coming in about in the 1890s, but certainly in Eastbourne, I wouldn't recommend that you filled your cavities because you've got a huge water ingress issues with your climate being right by the sea. Suspended timber floors. So timber floors, obviously, they're not insulated, and you need to keep the airflow going to keep your building healthy when it's an older building. But obviously, to reduce energy consumption, you want to seal the building up tightly. So you need to look at ways of which you can do that without changing the way the building works, because if you start shoving in lots of modern interventions into a building, it's going to actually cause you problems potentially with condensation and risk and mould and that sort of thing. So you've got bay windows. I put dodgy energy systems. When I moved into my Victorian office, we had a heating system that would work sometimes, and invariably it would make lots of shuddering noises before it finally started working, and you had to actually hit it with a hammer to actually get it going completely. And these kind of dodgy systems, they use a lot of energy. So looking at your energy systems is an important part. Now, I know a lot of this conference is about those energy systems, but I would say that there are other issues that could actually reduce your energy consumption as well. Pitched roofs, flat roofs, no roofs. In older buildings, we often have a lot of skeelings, so that's the sloping bit, and it's very tempting to put insulation to the underside of them, but you need to be very careful where you put insulation in buildings, because if you insulate too much, the rate at which your water comes, or water vapour, warm moist air, goes through the insulated layer, hits a cold surface, and it condensates too quickly, causing black mould. And I think I've got a little slide on this later, but that does actually make quite a difference. That's a health risk. So if you're looking at insulating your building, if you can, you need to be very careful about the sort of materials that you use for it. Not yet, Jill. Open fires and chimneys. So these are really important for the health of the building. In the old buildings, obviously your chimney was actually really important for bringing in fresh air throughout it. So if you block it up, you're actually changing the way the building works. So you need to think very carefully. I don't know how many of you suffered from damp from blocked up chimneys, but it's a really common occurrence. You need to ventilate them when you change the way the building is. Okay. So this is a slide which I haven't actually referenced, and I need to. It's from Paul Jennings at Aldous, who is probably Britain's leading air tightness expert. So when you're looking at your building and you're sitting there and the heating's on and you're wondering why it's getting so cold, it could be because it's losing heat through air leakage. And when I was talking about passive house earlier, so passive house came about from a professor called Wolfgang Feist in Germany, obviously from Germany, because all the good things energy-wise seem to come from Germany. And he looked at a building, and he put like solar panels on and all these sort of like what we call bling per se, and measured the energy consumption of that building. And the energy consumption did not reduce, which is why he then went back and looked at the building differently in terms of physics. So I imagine heat as a liquid. And if you imagine heat as a liquid in a fishbowl, and there's holes in the fishbowl, and the water will pour out, and that is what the heat in your building is doing. It's pouring out through all the air leakage. Now, obviously, in a Victorian and Edwardian building, you've got to be really careful about how you restrain that air leakage. You want to have controlled ventilation. You don't want leakiness. But at the same time, you've got to think about the health of the building. So you can see, I mean, I don't know how many, 25 You know, when an electrician comes along and puts your security lights, there's another hole. Plumbing differences, there's another hole. When you start looking at a building like this, it's like another set of clothes. You wouldn't go out in a cold day with like a jumper on top and, well, you might do actually, and a little miniskirt and leaving your midriff. That would obviously lose you lots of heat. So insulation is the same, but obviously in Edwardian and Victorian buildings, if you've got bay windows that are beautiful on the outside, you can't insulate them. You can't insulate inside when you've got a historic building and historic features. You could possibly do the floor, and you can do the attic. Then you've got to focus on windows and air leakage and infiltration. Okay, next. How am I doing on time?
I've got about 6 minutes left.
Oh, 6 minutes. Oh. So I thought it was really interesting to actually look at what uses the energy in your home, because if you want to reduce your energy consumption, 60% of it is going to be in heating and hot water. So it's really worth looking at those systems that are, you know, to maybe improve the efficiency or get something new in for those. But there are other things as well, lighting. Obviously, LED lights, light-emitting diodes are just brilliant. I love them. Your refrigerator uses an 8%, which is, I think, is really high. I mean, everybody has these big American fridges. Do you really, really need them? Could you have a smaller one? Washers and dryers, ovens, blah, 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 blah. Okay, next. So retrofit, where do we start? The project definition triangle, cost, specification, and time is really, really important. And when you're considering what you want to do, I would recommend that you do an air test, and that's what that little film was about, which is available through a website. It's very embarrassing because I'm an eco-architect and my building is shocking, but it gives you lots of helpful hints and makes you understand your building better. So you can see how a bay window leaks here. Very, very interesting. A measured building survey gives you plans and elevations so you can actually work out where you're going to insulate, etc. And then there's this getting your building retrofit ready. Next. This is just a couple of images from my office here, just showing how the heat comes out of your building. I think that's really good. Well, it's not good, obviously, it's really bad, but next. Retrofit ready. So this is one thing that people don't understand. They come with a budget. They say, I want to spend £150,000 on doing all this work. But first of all, you've got to make sure that your building is retrofit ready. It needs to be repointed. It needs to have all its gutters cleaned. It needs to make sure that all the sash windows work. Maybe fit draft proofing. This, on the right-hand side here, we've got some haunching that has sort of fallen off, things like that. And that can take up to 25% of your budget, which is a huge amount, and people just don't understand that. Next, please. So reducing your energy consumption with a whole building approach, because I haven't got very much time today, I haven't really touched on the ways that you can actually do it, but I would always recommend in old buildings that you use breathable insulations, natural materials to ensure the building is integrity. So my slide here is that we're burning money, because a lot of the time we are burning money in the way we use our building. So it's not just about, oh my God, I must go out and buy something that will make me be really energy efficient. You actually need to address the way you use your building in the first place. And I think that's the number one. You can make some really good gains by, you know, not having 50 million lights on, but maybe only having 5, things like that. Okay. Older buildings were built to leak. That's how they did it. I came across, when I was researching for this talk, I came across a little plaque that was issued by a builder on some houses pre-war, or it might have been between the wars, where they said that you had to keep your bedroom window open throughout the summer and the winter because it was very healthy, and if you didn't, you'd have to spend money with a doctor because it would make you ill. So there was this perceived notion that fresh air is actually really, really good for you. Well, of course, if you've got a cold building, it's not necessarily very good for you because you get condensation, which forms on any sort of like single glazed window, and on the walls where there's a surface differentiation, in our modern houses, we heat internally so much higher, so it's very different to an older building. So you maybe perhaps consider living at slightly lower temperatures in an older building than a modern building. Yes, next one. I'd also like to point out at the bottom that a lot of these slides come from the Historic England. There's some very good free pamphlets that you can get. This one is Energy Efficient and Historic Buildings. And if you just go on Historic England online, you can download these. They're very, very useful. Historic England is a very anti-passive house, I would just like to say. So there is, some dichotomy there. This is just... So the last few slides are just to look at potential things that you could do. Everybody knows about replacing your windows. But the thing is that they can be quite damaging to your building. And it can be damaging to the way the building looks. I mean... I've got UPVC windows in my office building because I had replacement 60s. I'm justifying it. The character of timber windows is irreplaceable. I've just got a Victorian 130-year-old sash window that I'm just refurbished. A plastic one, I would have to throw it away after 20 years, and modern softwood or even modern hardwood will probably go after like about 20 or 30 years. If you can keep your historic windows and secondary glaze, draft proofing, they were sort of similar carbon savings, similar energy savings, much more kind to the heritage of the building, which I find very important. Technical risk, is that an orange or a red?
That was a red.
Oh, it's a red. Right, next. This is just an example of draft proofing. I'm a massive fan of draft proofing. Next one. And then, so internal and external wall insulation is really, really important. You cannot put loads of it. When you use it internally, you have to be very careful. Otherwise, you get that interstitial condensation thing that I was talking about. And then the final couple of slides are just to show you that retrofitting is really, really, really invasive. So you can rip the building apart. So you really need to think about how to do it. If you can move out, move out. Obviously, you might need to keep your office going. Oh, you've gone back. Yes. You are, okay. Yes, you just get very many different types of floor makeups as well. Okay, so final slide. Thank you for listening. This one, I love this one. So this is the oldest Enefit certified, which is a passive house retrofit certified. And you can guess which building, obviously, it's by Andy Simmons. And that's what you get if you retrofit your building. Thank you.